Hello viewers, welcome back to another section of my tutorial video. In this video, we're going to solve Bernoulli differential equation problems. I'm going to take you through the concept of Bernoulli differential equation, then we will solve a problem. When we say Bernoulli differential equation, it's also a type of differential equation, and we have a way of solving that one too. But this type of differential equation is similar to the linear differential equation, that is first order linear differential equation. Please watch this video to the end and make sure you subscribe. All Bernoulli differential equation is in the form y prime, that is your derivative will stand there alone, plus p of x multiplying y, sorry I omitted, then it will be equal to q of x, that is any other function or constant other than y, or which is not attached to y, will come here. But there is a y here to the power n, that can be y squared y to the power 5. That makes it different from the linear, because the linear has this, and has this, but this alone is a modification of the linear differential equation. So how do we tackle Bernoulli differential equation? To solve for Bernoulli differential equation, you divide through by this new term here for every parameter you have in this equation. So you first have y to the power negative n, right? Because when you divide through by this, you get negative n multiplying y prime. Then you get plus, you divide it by this side too, then you get p of x so you get p of x, but in this time you realize that you have y already here. So when y over y to the power n, what do? We apply the laws of indices, and the laws of indices will say that you have a power of 1 here which you don't write, so you get y to the power 1 minus n, y to the power 1 minus this new n, and that is going to give us q of x, right? So realize that you have removed the y to the power n here by dividing through by that particular term of the equation. So q of x. So this is the next step, and what you are going to do again is that you let a variable, let's say v or u, any variable, to be equal to the coefficient of p of x, that is this. You let a variable represent y to the power 1 minus n. Then you are going to differentiate this variable, and you will do the necessary steps in the later part. But let's see what you're going to do. So if I differentiate this variable with respect to y, you realize that I'll get v prime to be equal to, I'll get this multiplying the whole thing, so 1 minus n, right? Y to the power, what you have here, minus 1. So if you have what you have here minus 1, then you can see that I'll get what? Negative n. Is that not it? So when I get negative n, whenever you are differentiating with respect to y, you are going to add the y prime itself. It's implicit. So the v over the dy, you have y, so y dy over the x. But here it's going to be y prime. You get it? Because you are differentiating with respect to y. That is the implicit notation. So we are going to see that I have my y to the power negative n, y prime here. And it's the same thing I have here. So I can make this the subject here and change the variables or the parameters in my equation. So gradually we are proceeding, and at this point I'm going to make this whole thing the subject so that it will look like this. So when I make this the subject, I'll get v prime over 1 minus n, right? 1 minus n, as I have here, I'm dividing through by 1 minus n. So I'm going to get my v prime here divided by the coefficient here. So that's going to be 1 minus n. So I'll remove this and I'll put this one there. And I know that y to the power 1 minus n2 is the same as what? V. Is that not it? So plus p of x then I have my y to the power 1 minus n being v, and all this will be equal to q of x. So I've changed my variables from y to v, and I can now simplify it in the linear form, the first order linear form, right? So this is simple. So I can simplify this now. So once I have this, I cannot use the linear. I'll find my integrating factor, then solve for v. Then I'll come and make it y the subject here. And that is how we solve Bernoulli's differential equation. Now let's take an example and get things right better. So I'm going to give you an example here. So I have my y prime plus 4 over xy So see this question I have here. Y prime plus 4 over xy is equal to x cubed y squared. So this y squared is a term that makes this look what? Bernoulli. So whenever you see an equation and you see it in this form, you just click your mind, this is Bernoulli's differential equation. So now what do we do? First step, number one, you are going to divide through by what? This term here, which is y squared. That's the first thing you are going to do. Divide through the equation by this, and that is going to give me y to the power negative 2. Then I'll bring my y prime plus, when I divide through by here there's already 1 here. So 1 minus 2 will give me negative 1. So my 4 on x, then I'll have this y being negative 1 to the power. So that it's like when you divide, you get 1 minus 2. Yes, it was 1 minus n, here is 1 minus 2, negative 1. And that is equal to s cubed. So this is the first step in solving every Bernoulli's differential equation. You divide through by our by our term y to the power n. So at this point, I told you choose a variable, let's say v, right? Then that v will be equal to the coefficient of the p of x, and now it's 4 over x. So will be equal to our y to the power negative 1 here. So when I have this, the next thing is to differentiate this with respect to y. So v prime is now equal to the negative 1 will multiply it, so it will be negative y to the power. I'll subtract 1 here, so that one will be minus 2. So I'll get negative y to the power negative 2 Then I told you we'll introduce our y prime. Since you are doing implicit, you introduce your y prime to it. Then now, when you see this, it's equal to what you have here. So you make that a subject. When I make that a subject, it's giving me negative v, right? I'll divide through by negative 1. I'll divide here by negative 1. And that is where I'll get the whole of this represented by what? Negative v. So I'm rewriting the equation negative v plus 4 over x then my y prime here is what? V. C is v, and everything will be equal to my s cube, right? So that is changing the variables as we have to the new variable v. That is exactly what we did. So this is the second step too. Now let's see. Finally, we have got a linear differential equation. So we are simply going to solve this using the first order linear differential equation. If you are new to that, kindly go back to my video to subscribe, then you turn on the notification button. Go back to my videos in the first order linear differential equation, then you are good to go. So let's see. At this point, we are going to find our integrating factor mu of t, and so my integrating factor mu of t is going to be, we use a formula to find the integrating factor mu of t, and it's equal to integral 4 on x, then you have e at the base, so e to the power the integral of what? 4 on x. Now since I'm using x, it will be mu of what? X, not t, sorry. So this place is mu of what? X. Then I'll bring my dx here. So now I'll found my integrating factor. So what did I say the integration factor is used for? So what I said is the integrating factor is going to be multiplied throughout the equation. So now let's find the integrating factor. Integral of this is going to give me 4 ln x, right? 4 is a constant, and integral of 1 over x is ln x. You have to go and memorize your calculus so that you understand differential equation better. So my integrating factor is simply equal to, when this one comes out, I get integral of 1 over x, and that will be 4 ln x, right? So I'm going to get e to the power 4 ln x. So when I get the 4 ln x, I'm not done. You realize that there is a property in logarithm that when you have e to the power a ln, then I can bring the 4 here so that I'll get ln to the power. So see, I'll get e to the power ln x to the power 4, and e to the power ln will cancel and give us what we have here. So our integrating factor will then be equal to x to the power 4, right? So I made a mistake here which I need to correct. Before I would have chosen the coefficient of v here, please always your integrate your first order linear differential equation should have the derivative here to stand alone. Here it was -1 here, so I need to divide through by what? Negative. So this one will turn negative and this will turn negative. And sorry for that mistake. So at this point I'll take this off, then I'll introduce my negative. So now the coefficient of v will have negative here. So realize that here I'll have -4 ln x, then I'll get x to the power -4 here. So here my integrating factor becomes x to the power -4, right? That is my integrating factor, x to the power -4. So once I get my integrating factor, I'm going to multiply through my equation by this integrating factor. So now I have my equation. Here is positive, here is negative. Take note. So I have it to be v prime multiplying x to the power -4 then plus, you are going to multiply the integrating factor by every term. So plus our x to the power -4 then -4 over x then your v will come. Then all this will be equal to, you see here I have -s cubed, right? So if you have -s cubed and you multiply it by -x to the power -4, what are you getting? So here I'm going to get -s cubed multiplying x upon -4. 3 plus -4 will be -1. So I get -x to the power -1. And this is where I am. I told you that in first order linear differential equation, if you get such an expression, it's simply your v and your integrating factor multiplying to be the derivative of their product. So v multiplying x to the power -4. So the -4 to the x, and everything I have here all will be to the power prime, and it will be equal to, I have here c negative x to the power -1. So at this point I'm going to remove this prime I have here so that I make v the subject. That is my goal. So to make v the subject, I'm going to take integral on both sides. So integral of v multiplying x, so this is my v, x to the power negative 4 and I have my prime outside. Then it's going to be equal to the integral of negative x to the power negative 1. So at this point, you can see that this prime here will cancel our integral here, so that part you will not tackle it. Then our focus is going to be on this side alone. So let's see how we're going to do that. So this has cancelled this side. Then you are going to have this our negative. So we have our v multiplying x to the power negative 4. This one here. So x to the power negative 4. And how do we compute the integral of this side? So that's going to be the problem. From calculus, if you have the integral of what? 1 over x, this is the same as 1 over x, take note. So this is the same as integral of 1 over x. So this is negative, it's just a constant to come out. So when a negative comes out, when you have the integral on 1 on x, you are going to get what? Negative ln x. So we get negative ln x, then plus our c, which is a constant. So once we get this, then we are simply going to divide through by what? The coefficient of v, so that we get v standing there alone. Then you divide each. Then for all of them, x to the power negative 4. So this side will cancel this. Then this is our x. Sorry for lane writing. So this will cancel this. Then now, this is where I am. So I'll have my v alone. So my v is simply c equal to negative ln of x this side all over x to the power minus 4 then plus c x to the power 4, because this is negative already. So I have c x to the power 4. So at this point, I'm done and my equation is in v, but that's not the original equation. One key part of Bernoulli's differential equation is that one key part of Bernoulli's differential equation is that after you get your answer in the new variable, you need to express it back. So you realize that wherever we find v is the same as what? Y to the power negative 1, right? So once we get this, we need to put it back. So wherever I see v in our equation, put y to the power negative 1. So let's get back to what we're doing. So at this point, this v becomes y to the power what? Negative 1. Y to the power negative 1. And it's equal to all the terms you have on this right side. Negative ln x on x minus all over x minus 4. So plus c x to the power 4. So now our solution is now in y to the power negative 1. So you need to express it in the form y equals, right? Or this 1 over y. So we simply have our solution in the simplified form. We just interchange the position of y, then we are done. Sorry for the delay. So here will be 1 over y, right? So the y will come here and everything here will come. So I'll have 1 over the expression negative ln x all over x to the power minus 4 plus c x to the power 4, and that will be equal to y. Thank you for joining me for this section. This is the solution for our differential equation. You choose a variable, you use the first order linear differential equation to solve in terms of that variable, then we make the subject for our actual or original variable. Thank you.